From ancient times to the modern battlefield, the thunder of artillery has been a constant presence in warfare. The roar of these powerful weapons has echoed through the ages, from the rudimentary catapults of ancient civilizations to the sophisticated artillery systems of today. Each era has seen its own advancements, each conflict its own innovations, but the fundamental principle remains the same: to project power over distance and to dominate the battlefield through sheer firepower. Artillery, the use of large-caliber guns for long-range bombardment, has played a decisive role in shaping the course of history. These weapons have been pivotal in countless battles, turning the tide of war and altering the fate of nations. From the trenches of World War I to the deserts of the Gulf War, artillery has been a key factor in military strategy, providing the firepower needed to break through enemy defenses and support advancing troops. These powerful weapons have the ability to deliver devastating firepower over vast distances, breaking enemy lines, demoralizing troops, and paving the way for advances. The psychological impact of artillery cannot be underestimated. The constant threat of bombardment can wear down even the most seasoned soldiers. The sheer destructive power of artillery shells, capable of obliterating fortifications and creating craters in the earth, has made it a fearsome tool of war. The impact of artillery on warfare cannot be overstated. It has not only shaped the physical landscape of battlefields, but also the strategies and tactics employed by military leaders. The ability to deliver concentrated firepower at critical points has made artillery an indispensable asset in both offensive and defensive operations. Its presence on the battlefield can dictate the movements of troops, the placement of fortifications, and the overall conduct of a campaign. Its evolution has been driven by technological advancements and the ever-present need for military superiority. From the development of gunpowder to the invention of rifled barrels, each innovation has increased the range, accuracy, and lethality of artillery. Modern artillery systems, equipped with advanced targeting and guidance technologies, can deliver precision strikes with devastating effect. The continuous improvement of these weapons reflects the ongoing arms race and the relentless pursuit of battlefield dominance. Understanding how artillery weapons are fired and destroyed provides valuable insights into the dynamics of warfare and the constant struggle for dominance on the battlefield. The process of loading, aiming, and firing an artillery piece requires skill and coordination, while counter-battery fire and other methods of neutralizing enemy artillery demand equally sophisticated tactics. Studying these aspects of artillery warfare reveals the complexity and intensity of modern combat. This essay will delve into the world of artillery, exploring its history, the mechanisms behind its firing, and the methods used to destroy these formidable weapons. We will examine the technological advancements that have transformed artillery from simple siege engines to the highly advanced systems used today. By understanding the evolution of these weapons, we can gain a deeper appreciation for their role in shaping the course of history and the nature of warfare. From the early days of catapults to the sophisticated artillery systems of the 21st century, we will examine the evolution of artillery and its enduring impact on warfare. This journey through time will highlight the innovations and advancements that have made artillery a cornerstone of military power, demonstrating its crucial role in both historical and contemporary conflicts. Join us as we explore the thunderous world of artillery and its profound influence on the art of war. The earliest forms of artillery were simple mechanical devices designed to hurl projectiles at enemy fortifications and formations. The ancient Greeks and Romans employed catapults and ballistae, using tension or torsion to launch large stones, arrows, and incendiary devices. These early artillery pieces, while rudimentary by today's standards, were instrumental in sieges and open battles, providing a significant tactical advantage. With the advent of gunpowder in the Middle Ages, artillery underwent a profound transformation. Cannons, initially crude and unwieldy, emerged as the dominant force on the battlefield. These early cannons, often cast in bronze or iron, fired heavy stone or iron balls, capable of smashing through castle walls and decimating enemy ranks. The development of gunpowder-based artillery marked a turning point in warfare, ushering in a new era of firepower and strategic bombardment. At its core, an artillery piece is essentially a large tube, closed at one end and open at the other, designed to launch a projectile over a long distance. These formidable weapons have been a crucial part of military strategy for centuries, evolving from simple catapults and trebuchets to the highly sophisticated cannons and rocket launchers we see today. The basic principle, however, remains the same: to deliver a powerful blow to the enemy from a distance, minimizing the risk to one's own forces. The principle behind firing an artillery weapon is relatively straightforward. A controlled explosion propels a projectile, typically a shell or rocket, out of the barrel at high velocity. This controlled explosion is a marvel of engineering, requiring precise calculations and timing to ensure the projectile hits its intended target. The sheer power and speed at which these projectiles travel can be awe-inspiring, often reaching speeds of several hundred meters per second. This explosion is generated by igniting a propellant, historically black powder, and in modern times smokeless powder within the firing chamber. The transition from black powder to smokeless powder marked a significant advancement in artillery technology, allowing for greater range, accuracy, and reduced smoke, which in turn improved visibility on the battlefield. The choice of propellant can greatly influence the performance of the artillery piece, making it a critical component in the design and operation of these weapons. The burning propellant produces a rapid expansion of hot gases, creating immense pressure that forces the projectile down the barrel and out towards the target. This process is a delicate balance of physics and engineering, as the pressure must be carefully controlled to avoid damaging the artillery piece while still achieving the desired range and impact. The design of the barrel, including its length and the materials used, also plays a crucial role in managing this pressure and ensuring the projectile's stability during flight. The range and trajectory of the projectile are determined by a combination of factors, including the amount of propellant used, the angle of elevation of the barrel, and the design of the projectile itself. Modern artillery systems often incorporate advanced targeting and guidance systems, allowing for greater precision and adaptability in various combat scenarios. The shape and aerodynamics of the projectile can also significantly affect its flight path, with some designs optimized for maximum range, while others are tailored for specific types of targets or missions. Understanding these factors is essential for effectively employing artillery in both offensive and defensive operations. Section 4. Aiming the storm sights and calculations. Accurately hitting a target with an artillery piece requires more than just raw firepower. It demands a blend of science, skill, and meticulous planning. Precision and careful calculations are the cornerstones of effective artillery use. Without these, even the most powerful weaponry can miss its mark. Artillery crews employ a combination of sights, instruments, and mathematical formulas to determine the correct aiming point for their guns. This process is both an art and a science. Using maps, compasses, and specialized instruments like aiming circles, artillerymen first determine their position relative to the target. This initial step is crucial for setting the stage for accurate fire. Artillerymen use a variety of tools to pinpoint their exact location. Modern technology, such as GPS devices, has enhanced this process, making it more precise than ever before. They then factor in variables such as wind speed and direction, air temperature, and humidity. These environmental factors can significantly influence the path of the projectile. Another critical factor is the rotation of the Earth, known as the Coriolis effect. This phenomenon can cause the projectile to drift off course if not properly accounted for. All these elements are meticulously calculated to ensure the projectile follows the intended trajectory. The margin for error is minimal, and every detail counts. With these factors accounted for, the crew calculates the appropriate angle of elevation and direction, known as azimuth, to aim the gun. This step is where the science of ballistics truly comes into play. The angle of elevation and azimuth are adjusted with precision instruments, ensuring that the gun is aimed accurately. This process requires a deep understanding of physics and mathematics. This process, often requiring complex trigonometry and tables of ballistic data, ensures that the projectile will land on target with a high degree of accuracy. The calculations are double-checked to avoid any mistakes. The culmination of these efforts is a precise and devastating impact on the target. The combination of technology, skill, and meticulous planning ensures that the artillery fire is both effective and accurate. Section 5. Modern artillery, precision and power. Modern artillery systems represent a pinnacle of technological advancement, combining devastating firepower with remarkable accuracy. Contemporary artillery pieces are often mounted on self-propelled platforms, providing enhanced mobility and responsiveness on the battlefield. Advances in material science have led to the development of lighter, stronger barrels, capable of withstanding higher pressures and firing projectiles at greater velocities. Sophisticated fire control systems, utilizing computers, laser rangefinders, and GPS navigation, have significantly enhanced targeting accuracy and reduced the time required to engage targets. Moreover, the introduction of guided artillery shells, equipped with onboard sensors and fins for course correction, has further increased precision, allowing for surgical strikes on high-value targets with minimal collateral damage. Section 6. Counter-battery fire, silencing the guns. Given the destructive potential of artillery, neutralizing enemy artillery batteries has always been a top priority in warfare. Counter-battery fire, the practice of targeting and destroying enemy artillery with one's own guns, has been a key tactic since the early days of cannon warfare. Historically, counter-battery fire relied on sound ranging and flash spotting, using the sound and light emitted from firing guns to triangulate their position. Modern counter-battery operations utilize sophisticated radar systems and acoustic sensors to detect enemy artillery fire. These systems can quickly pinpoint the location of enemy guns, allowing for rapid and accurate counter-battery fire, often before the enemy shells even land. The effectiveness of counter-battery fire lies in its ability to disrupt enemy operations, silence their guns, and protect friendly forces from bombardment.